This video is a follow-up to our base example where we published our real-time sensor packets to the public Eclipse MQTT broker. In this example, we'll modify the configuration file we used in the original example to instead publish our packets to a cloud-based Ubidots dashboard. Before we begin, it's assumed that you've watched the base example and are familiar with the SoftHub's MQTT capabilities as well as Ubidots dashboards. If not, there are links in the video description to direct you to the relevant documentation and videos. We'll start by opening the ruleengine.xml file from our previous example. The only thing we'll need to modify in this file is the publish data action object. We'll first change the message topic per the Ubidots documentation. Note that the actual device we specify in the topic string is copied from our Ubidots device API label. Next, we'll change our target broker address from the public Eclipse broker to the appropriate Ubidots broker for our account type. We'll specify an external MCFG file that we'll use to reformat our outgoing JSON packets to be compatible with the Ubidots broker's requirements. And lastly, we'll plug in our Ubidots default token as our server username. That's all the changes required to the rule engine file to redirect our packets from the Eclipse broker to the Ubidots broker. The rest of the rule file remains unchanged. We'll save our file and push it over to our SoftHub device using the pscp command. On our SoftHub device, we'll copy the template MCFG file to the file name we specified in our rule engine file. We'll edit the file and make 3 changes. First, we'll enable the flattening of our outgoing JSON packets. This is required to use the SoftHub's on-the-fly JSON filter format packet reformatting feature. Additionally, we'll specify that the SoftHub not publish any packets that are not successfully reformatted, and we'll specify a single JFF file that will describe our packet transformation. We only need one JFF file because in our scenario we only output a single packet type. For our JFF file, we similarly start by copying the JFF template file to the file name we specified in our .mcfg file. We'll then edit our new file to provide the directives needed to reformat our outgoing packets to meet the input format requirements for the Ubidots broker. We'll need to pull 4 values from the outgoing packet that we'll plug into the transform packets we publish. This is the packet we captured from our original example, and this is the same packet in a flattened format. You can get the flattened format by either running the original packet through one of the many online tools available or simply publishing the packet to the Eclipse broker in a flattened format. For our Ubidots dashboard to properly display our data, we need to translate our flattened data packet into the format acceptable to the Ubidots broker. This is an example of what our reformatted original packet should look like per the Ubidots documentation. We've plugged the values from the flattened packet into the Ubidots template packet as illustrated. So now we'll just build our JFF file to specify the same transformations. We'll provide the JFF file with the labels of the data fields we want to plug into our template string from left to right. Following that scheme, we provide the label for the current temperature, followed by the packet timestamp, followed by the current humidity, followed again by the timestamp. Note that the timestamp will also be translated from an ISO format to a Unix timestamp. This is indicated by the number 2 we've suffixed our timestamp labels with. See the SoftHub MQTT documentation for further information. Lastly, we'll provide the actual output packet template string. Note that the value labels for each must match the API label names for the target device variable you wish to graph on your Ubidots dashboard. With that, we'll save our JFF file and restart the SoftHub daemon. Switching over to our Ubidots dashboard, we can see our display widgets begin to update with the real-time data being published from our SoftHub device. Again, this video is meant to just provide the simplest example of how to get your data to your Ubidots dashboard. Both the OmnIoT SoftHub and the Ubidots platforms provide far more features than we've touched on here. One additional feature is the ability to control your SoftHub device remotely from your Ubidots dashboard using a control widget. Be sure to check out our follow-on video where we'll update this example dashboard with a simple remote control widget.